Derivatives of inverse functions. Alright, so before we go ahead and start looking at formulas, what I want to do is look at the graph of f of x equals 2x minus 1, so this is a linear function, and its inverse function, f inverse of x, is 1/2 x plus 1/2. So each of these are graphed on the following xy plane. So this blue graph is f of x equals 2x minus 1, positive slope 2, y-intercept negative 1, and f inverse of x is the red graph 1/2 x plus 1/2. And so notice that since these graphs are inverses, the red graph is a reflection of the blue graph over the line y equals x. So this lighter line right here, that is the equation y equals x. So two functions are inverses if they reflect over the line y equals x. So in other words, whatever this coordinate point is here, exactly over the line y equals x, there's going to have to be a point on the graph of its inverse. So what I want to do is I want to think about slopes, because we're talking about derivatives, so we're thinking slopes of tangent lines. Here's a line and its inverse. And now there's an analytical way of finding the inverse of a trig function, and it involves switching the places of x and y, and it's only possible in certain cases, but that's a pre-cal topic. So for now, what I want to do is think about the slopes of these two lines. So the slope of the blue line, the original function, was 2. So my m value is 2. And if you notice, the graph of the inverse of x has a slope of 1 over 2. So if I call this value 2m, then 1 over 2 means that my inverse has a slope of 1 over m. And it turns out that's going to be the relationship between a linear function and its inverse. So only for a linear function is the slope of the inverse line going to be the reciprocal. So I don't want you to get this confused with perpendicular. This is an opposite reciprocal. It's just the reciprocal. So the slope of f of x as a line was 2. The inverse of f of x is going to have a slope of 1 over 2, so 1 over m. And let's talk about how this is about to connect to finding the derivative of the inverse of any function, not just a linear function. Alright, so in this first example, I want to find f inverse prime of 1 given f of x equals x plus e to the x. And I'm actually starting out with one of the more difficult examples, but it's a really good chance to go step by step through this type of problem. So I want f inverse prime of 1. And we're going to apply the formula for the derivative of an inverse function, which is f inverse prime of x equals 1 over f prime of f inverse of x. So in this case, my x value is 1. So I'm going to replace each of these x's here with a 1. So let's start out. I want f inverse prime of 1, which is 1 over f prime of f inverse of 1. So that's the first step, just substituting the value I'm looking for, the x value, into each x. Well, now I have to work inside parentheses first, so I am following order of operations. What I need is f inverse of 1. That's what I'm looking for, given f of x equals x plus e to the x. So f inverse of 1 means that I want to find the x value that I have to plug into f of x to get out the value of 1. So here's what we're not going to be doing. We're not going to be explicitly finding f inverse of x so that I can plug 1 into f inverse. That's not the point of this section. So what we're going to try to do instead is figure out what value do I have to plug into x, so this x and this x, so that I get out the value of 1. So what number plus e to that same number is going to give me out a 1? So I'm looking for a number to plug into each of these blank spaces, and they have to be the same value. So the best thing to do is guess and check. Really, the only thing we can do is guess and check, but we're going to start with 0, and then try 1, and then -1, and 2, and -2, until we get the right x value. So we're never going to get some really weird values. It's always going to be a pretty low integer value. So if we start with 1, if I substitute in 0, 0 plus e to the 0, well, 0 is just 0, plus e to the 0, anything to the 0 is 1, so 1 equals 1. So yes, this does work out. So what we just figured out, so I'm going to write it over here off to the side, we just figured out that f of 0 equals 1. So in other words, f inverse of 1 equals 0. And if you really want to convince yourself of that, I'm going to show you a little bit of additional work here. So what I can do is I can take f inverse of both sides. So f inverse of f of 0 has to equal f inverse of 1. So I didn't multiply both sides by f inverse. That doesn't make sense to say that. I took f inverse of both sides. Whatever I do to one side of an equation, I can do to the other. Well, f inverse next to f, an inverse next to an original function, cancels each other out. So this left side is just 0. So the right side stays f inverse of 1. So f inverse of 1 is 0. So that's what I'm substituting into this inside portion here. So the next part of my equality string is 1 over f prime of 0. Well, now I need to find f prime of 0, and I only have f of x. But I can find f prime of x so that I can substitute in 0. So let's do some more scratch work here. F prime of x equals 1 plus e to the x. So I'm taking the derivative of this function so that I can substitute 0 in. So f prime of 0 is 1 plus e to the 0, which is 1 plus 1, so that's 2. So now I can replace f prime of 0, this quantity in the denominator, with 2, so that my final answer is 1 over 2. So f inverse prime of 1. The first step was to plug the 1 into the formula, 1 over f prime of f inverse of 1. And from there, there's going to be 2 steps. Find f inverse of 1, find that numerical value, and once we do that, substitute that numerical value into f prime, into the derivative, but that means we need to find the derivative. And then finally, 1 over that derivative evaluated at that inverse number is going to be the final answer. So in this case, 1 over 2. Alright, so suppose f of 2 equals 3, f of 3 equals negative 1, f prime of 2 equals 1 over 2, and f prime of 3 equals 4. So we're not explicitly given the function f, but we're given pieces of information about f. So with these pieces of information, if possible, find f inverse prime of 3. So if possible meaning that we may not have been given enough information about f to solve this problem. And in general, we only need 2 pieces of information here, so we've definitely been either given too much information or not enough information. So it's really about understanding the formula so that we correctly identify the pieces of information we need. So I'm interested in finding f inverse prime of 3. So we're going to plug that 3 into the formula, 1 over f prime of f inverse of 3. So I have to work inside the set of parentheses. I need f inverse of 3. So let's look at those pieces of information again. The first 2 are involving the function f, and the second 2 involve f prime. So I don't need anything involving f prime yet. I'm interested in the original function f so that I can think about the inverse of f. So if I want this inside piece, if I want f inverse of 3, what I'm really looking for is what x value did I have to plug into f to get out a 3. So here, f of 2 equals 3. So the x value is 2 and the y value is 3. So what did I have to plug into x to get out 3? I had to plug in 2. So that means that f inverse of 3 is 2. So this piece of information is meant to throw you off. So they gave you f of 3 equals negative 1. But f of 3 is not the same as f inverse of 3. So I actually don't need this piece of information. Now, if you really want to convince yourself and show thorough work, what we can do is we can take this quantity, f of 2 equals 3, and take, again, not multiply, take f inverse of both sides. So now, f inverse next to f, inverse functions are going to cancel each other out. So the left side is 2, so 2 equals f inverse of 3. So that's how I'm able to replace f inverse of 3 with 2. So this equation becomes 1 over f prime of 2. Well, now I'm given two pieces of information about f prime. I want f prime of 2. That's exactly 1/2. So I don't need this last piece of information. I only need to substitute f prime of 2, which is 1/2, into the denominator. And now I don't want to leave a fraction inside a fraction, so this is 1 times the reciprocal of 1 over 2, so 1 times 2 over 1. So my final answer here is 2. So in this case, it was possible we were given enough information, and in fact, we were given too much information. Alright, this is the last example, and we're going to be given a table of information instead of the original function or just individual pieces of information. So at different x values, 1, 2, 3, 4, I know about the graph of f of x and f prime of x. And I'm told let g equal f inverse, find g prime of 3. So again, the best thing to do is write out a string of equalities. So I'm looking for g prime of 3. Well, g equals f inverse, so I'm going to replace g right now with f inverse prime of 3. Well, now f inverse prime of 3 has a formula that's 1 over f prime of f inverse of 3. So now what I'm searching for is what's inside the parentheses. I want f inverse of 3. So this is like asking, what did I have to plug into f to get out a value of 3? So I don't want to go to 3 up here as an x value and read off the f of x value, because that would be f of 3. So f of 3 equals 1. I really want to know, what did I have to plug in? What x value did I have to plug in to get out a function value of 3? So I'm going to look at the row of f of x and look for my y value of 3. So what x value did I have to plug in? I had to plug in 2. So that means f inverse of 3 is 2. So this equality becomes 1 over f prime of 2. So now, to find f prime of 2, I would go to the x value of 2, and now read off that third row. So f prime of 2 equals negative 3. So the denominator here is 1 over negative 3, which is the same as negative 1/3. So that is the derivative of g at 3, where g is f inverse. So that was that alternate way of writing an inverse and calling it a different function completely, calling it g. But we can still use that string of equalities so that we can follow our work carefully and make sure that we did use all the correct values that we needed.